olive oil, cola, non-cola. Okay, from the data, I have the force of the cup and liquid. I'm going to be measuring that in newtons. Now again, you should perform the experiment 3 times and take the average, which was 0.214, 0.234, 0.305, 0.283. And then just the liquid is going to be subtracting the force of Newton to the cups, which is 0.178. Again, this is in newtons. 0.199, 0.265, 0.243, which is going to be, again, taking this number and subtracting off the weight of the cup. Weight of the cup of the liquid, subtracting off the weight of the cup gives you the weight of the liquid. Now you want to convert that to mass. And again, force equals mass times acceleration, or mg, because we're dealing in the gravitational acceleration field. So therefore mass equals force divided by g. In this case we want to use g equal to 9.81. Take each one of these forces and divide by 9.81. And you should get the mass in kilograms as 0.0181, 0.0203, 0.0270, 0.0248 as a mass in kilograms. Now it's easy or straightforward to convert 2 grams. Just shift the decimal 3 to the right, because there's 1,000 grams equals 1 kilogram. You can easily do this conversion. Multiply this by 1,000 and you should get 18.1 grams. 20.3 grams, 27.0 grams, 24.8 grams for each one of these materials. Then in your volumetric cup, again, my units were in milliliters, so this is what I measured. 10 milliliters, 25 milliliters, 28 milliliters, 28 milliliters, giving a density calculation in grams per milliliter of the following: 1.81 for the chocolate, 0.812 for the olive oil, 0.964 for the cola, and 0.896 for the non-cola. So let's recap. This column is what you would measure the force on your force sensor in newtons with your liquid and the cup. Before you did the experiment, you'd measure the weight or the force of the cup, 0.04. This column is determined by taking this column and subtracting 0.040 newtons, resulting in the weight force of the liquid. This column is calculated by force equals mass times acceleration to determine the mass. This is the force, or weight, divided by the acceleration of gravity, 9.81, and you get this column. This column is obtained by converting from kilograms to grams. There's 1,000 grams in a kilogram. The milliliters is going to be the volume of the fluid that you poured in and measured the milliliters of the solution. And the final, the density, is going to be the grams over the milliliters. So you take this column, 18.1, and divide by 10. And you get 1.81 grams per milliliter. 20.3 divided by 25 results in this. Doing the division, that gives you the density in grams per milliliters. Okay. Again, your homework assignment is to recreate this using your 3 non-toxic fluids from home, determining the density of those. Also the percent error. So you're going to have to do a little bit of research using the internet. You can use a search engine of your choice to calculate percent error. Percent error is simply the measured minus the accepted, which is what you find on the internet, because you can believe everything on the internet, divided by the accepted value. Again, the percent error is the measured value, which are going to be these, minus the accepted, which is what you find either in a book or on the internet. And then you divide it by the accepted. You take the difference and take the absolute value, so you always have a positive value. Let's go through a practice calculation for percent error. I'm just going to make up a number for simplicity to do this, to show you the calculation. And let's say I determine the density of water. Density of water, I ended up getting, and I'm going to change the units on this, and let's say I calculated it to be 1001 kilograms per meters cubed. That's going to be, when I weighed everything out, divided it by the volume, I would get a measured value of 1001. Find on in any type of source that the density of water, this is going to be measured. The accepted is going to be 1000 kilograms per meter cubed. And then again, I need to divide by the 1000. Additionally, to make this a percentage, I need to multiply it by 100. Which results in absolute value of 1 over 1000 times by 100. Which gives me a 0.1% error. Now, depending on what you're doing, that would be considered good, or maybe not so good. But nonetheless, find your reported values. Those are going to vary depending on what liquid you chose. You could have chose milk. You could have chose orange juice. Many different fluids that you guys and ladies and gentlemen could have chosen. Alright, that concludes the second lecture for the differences between fluids.